Hello all, in this lesson we're going to be talking about proportions, and we're going to go ahead and give ourselves some good thorough definitions of what those mean. So, ratios that are equivalent are said to be proportional. Or you could say that those ratios are in proportion. Part of being a good mathematician is being able to talk the language correctly. Okay, so what is the definition of a proportion? It is an equation stating that two ratios are equal. Okay, maybe you got that. Let's talk about some characteristics. Two key characteristics. There is a scale factor between the ratios. That'll be very important. The second is that the cross products of the ratios are equal. Great. So let's take a look at some examples to see what we're talking about here. Okay, so 3/4, that's a ratio. This ratio is in fact equal to 9/12. This is an example of a proportion. We see that between the two ratios there is a scale factor. We could take 3, multiply by 3 to get 9, and that 3 is what we call the scale factor. The same thing is true in the denominators. We can multiply by 3 and we see that 4 times 3 is 12. Has to be the same scale factor both times. Okay, let's look at a second example. 5/6. That could be equal to 30/. You'll often see a missing number. And I'm sure some of you have already kind of keyed in on what that value could be because you saw that the numerators have a scale factor of 6. So the denominators will have to have a scale factor of 6. So in this case, x is 36. Great, those are proportions. What are some non-examples? Well, this might be kind of obvious, but 3/4 is not equal to, equals a slash is not equal to, 2/3. Those are both ratios, but they're not equal to each other, so this is not a proportion. It might be silly, but here, again, 1/2 does not equal 1/4. If I looked at the numerators here, 1 times 1 is 1, but 2 times 1 would be 2. So the bottom here has a scale factor of 2, the top has a scale factor of 1. So when we see different scale factors, not proportional. Okay, so one of the tasks we'll be posed to do in this section is to show if two ratios are proportional. So what am I going to require of you to show? You must show, we can do it by a scale factor method or by a cross product method. If you choose the scale factor method, you must show what scale factor you found, and I'm going to require an arrow showing the direction. We'll see why that's important in a second. Okay, so if we look at an example, let's say 2/8, and that's is it equal to perhaps 30/120. So let's go ahead and check this. If we're going to check this, we might go ahead and look from numerator to numerator. 2 times what is 30? Well, that's 15. So I'm going to show that with that arrow. And what about 8? 8 times, yes, once again, 15 is 120. So we see that this would confirm that, yes, they are proportions. This is an equal proportion. Okay, we could also look at, let's say, 2/8 again. And this time we'll also look at 25/100. So 25/100. You automatically might see, okay, I know that that's equivalent. But one thing you might see is 2 times what gives me 25. That's a messy number. Yes, there is a fractional scale factor that would work. But let's think about this. 2 times 4 would give us 8. And look, 25 times 4 would give us 100. So in this instance, we can use a scale factor, but move vertically. So the arrows are really important to show how we're finding if these numbers are in proportion to each other. So again, we would say yes, that these are proportional. Let's go ahead and let's talk about an example where they're not going to be proportional. So if we had 2 over 5, we're checking to see whether this is equal to 6 over 10. Let me put my question mark there. All right, so if I look at numerators, 2 times 3 would be 6, but on the denominators, we would take 5 times 2. Because we have different scale factors there, we are going to conclude, see, 3 there, 2 there, different scale factors. No, these are not a proportion. These are not proportional to each other. So that's the scale factor method. Let's also go ahead and look at a different method by using cross products. So if you're going to use the cross product method, which you're like, what's a cross product? We're getting there. The cross products in each direction is what you must show. Cross products in each direction. Great. All right, what are cross products? Let's look at an example. 3 over 7, 6 over 14. So yes, you could use a scale factor for this method, totally fine, but let's check something else out. If we start from the bottom, work up in a diagonal fashion, and we did 7 times 6. 7 times 6 is 42. I'm going to write at the end of my arrow of 42. Let's do the other diagonal. Moving up, 14 times 3, 42. Is that a coincidence? No, the fact that we got the same number when we did the cross products shows us that this is a proportion. We have equivalent ratios. So as we said in one of our definitions, or one of our characteristics, is the cross products of ratios are equal. This is what we're talking about. So yes, this is these two ratios are proportional. Okay, let's try another example. 6 over 15. What about, is it equivalent to 10 over 25? Is this a valid proportion? Okay, so by the cross product method, 15 times 10 would be 150, and let's see, 25 times 6. Once again, we get 150. Same number, yes, those two ratios are proportional. Now, if we'd started with something like 13 over 14 and 65 over 75, are these equivalent ratios? Is this a sound proportion? Well, we multiply this way, and calculators are permitted for this unit for me. So if I multiply this way, I get 910, and if I multiply this way, I get 975. Different numbers, meaning no, this is not proportional. These are not equivalent ratios. Interesting side bit that probably won't come up too much, because when we did the cross products, 975 was bigger than 910, the fraction 13/14 will be larger than the fraction 65/75. We could, of course, find an equivalent denominator and try to make them equivalent ratios, equivalent denominators, and then we could compare the numerators, but this is another method for seeing which one is larger. Okay, this is all about just checking whether two ratios are proportional if you have a proportion. Okay, what happens if we're looking to solve? We talked about in our definition that sometimes we might be having a missing number and we have to find that number. So if you're using the scale factor method to solve proportions, what must you do? You must write the scale factor and the arrow just like before, and you must state what the variable equals. Okay, let's look at an example, see just what we're talking about here. So if we had the ratio 2/7 equal to 14 over something, x. Okay, we're using our scale factors, so we look for the part of the ratio the part of the proportion that we know already. From 2 to 14, we see a multiplication factor of 7. That means the x here has to follow that same pattern. So if I take 7 and I multiply it by 7, the scale factor we saw for the numerators, that will give us our missing number here. So we showed our arrows with our scale factor. I don't want to see just 7 written as the answer. I would like to see x equals 7, because you're asked to find what the value of x is in a problem like this, so write a nice tiny little equation, x equals 7. If this was a word problem, which we'll get to later, you'll want to put 7 back into the context of the problem. Let's look at a second example. So let's say we have 3 over 12 is equal to something x over 28. We saw something like this before, but I can't think of a nice scale factor from 12 to 28. We could find a messy one, but that's not really worth our time. Now, vertically, I know that 3 times 4 is 12. So I have to multiply the numerator by 4 to get the denominator. But I don't know what x is, so I can't multiply by 4 to give me something. Now, some of you are saying, well, I can picture this backwards. I know what number times 4 is 28. Well, we're still going to be required to show what the scale factor is. So the scale factor is going to basically have to point towards the missing number, towards that x. So the scale factor here from 12 to 3, since you want to multiply down by 4, we're going to multiply up by its reciprocal, by 1/4. So that's going to be our multiplication. Our scale factors are always multiplication, so we're going to multiply by 1/4. Now, in your head on a calculator, you can do divide by 4 instead of multiply by 1/4. That's totally fine, as long as you can show and indicate that the scale factor here is 1/4. Oops, I was right, 1/4 again. So 28 divided by 4, or times 1/4, is 7. Okay, so those are examples where we solved a proportion using a scale factor. Well, we can also solve proportions using cross products. If you decide to do that, here's what you must show. You must write the cross product equation. Cross product equation. Great. You also must show all steps to solve the equation. Okay, so again, let's look at an example. Makes more sense when we do that sometimes. 2 over 7 equals 14 over x. We already solved this, but let's solve it a different method. So we talked before that the cross products are equal. So 7 times 14, that is one of our cross products. The other cross product is 2 times x. So what is 7 times 14? I'm just going to temporarily write 7 times 14 so we see where our work came from. Okay, that's one cross product. It must be equal to the other cross product. Well, how do I do 2 times x? We don't know what x is. That's okay. We're just going to write an expression. 2 times x is 2x. And yes, we want the number in front of the variable, nothing written in between. Nothing written in between implies multiplication. So exactly 2 first, then x, that means 2 times x. We don't know what it is yet, but that's the expression that represents this cross product. Okay, so let's go ahead. We have the cross product equation now written. So if I take 7 times 14, I get 98, and that's equal to 2x. I just brought that straight down. Okay, so if 2 times a number is 98, what do we need to do to 98 to find out what that number is? Well, we need to divide by 2. And so here's how we're going to show our work. Since we have 2 times the number here, we want to use inverse operations. So we're going to divide this side by 2 and divide this side by 2. So we divided by this side by 2 so that the 2's would cancel. 2 divided by 2 is 1, so we have 1x left. So it's all by its lonesome. Now we can figure out what the value of that is. Since we divided the right-hand side of the equal sign, picture a scale. We divided this side by 2. If you do the same thing to the other side, your scale will still be balanced. So over here, 98 divided by 2 is 49, and that is the value of x. Great. Some of you need to catch me when I do silly things. Earlier I was saying multiply by 7, and clearly when we just did this here, you're like, excuse me, you meant to say 49 over there. Sometimes I make those mistakes. So hopefully you caught that if I did that in class. Okay, so 49 there. Was our answer for both of those answers. Okay, here we go. Let's try another example. 3 over 12 is equal to x over 28. Okay, so we know we've solved this with a scale factor method, but let's now try to solve it with a cross product method. Okay, so we multiply our cross products. This diagonal, 12 times x, is simply 12x. This diagonal, 3 times 28, that's going to give us, I'll even write it down here so you see where the number came from, 3 times 28. 12x is equal to 84. I am fine in general if you came directly to this step, here, instead of writing this 3 times 28. I can believe that you did that in your head or on a calculator. Okay, so go ahead. Now we have 12 times x, so we just want regular x. So we have to undo this multiplication here by dividing. So we divide both sides. I want to see both of these divided by 12s, and we get x is equal to 84 over 12 is 7. So that's the basics of how we can check to see if two ratios are proportional, and how we can solve a proportion if we have missing values.